Good evening. I am Jonathan Katz. I'm the director of the Global Health Institute. And on behalf of the Institute and our sponsoring partners, the International Division, the Nelson Institute, and the Office of Sustainability, welcome you to this great event that will surely be thought-provoking on planetary health, protecting our planet to protect ourselves. Dr. Howard Frumkin, who I've known and respected for decades, is a leading voice in this new field that links planetary changes to human health and calls us to find solutions for the health of both. New planetary challenges extend across all sectors, and as Dr. Frumkin will explain, even threaten the survival of human civilization. In this present human-dominated era, now officially labeled as the Anthropocene. Now, it is a very special honor and pleasure for me to introduce Sarah Mangelsdorf, the Provost and Vice Chancellor for Academic Affairs at the University of Wisconsin-Madison.
Well, before I introduce tonight's speaker, I would like to tell you a little bit about the important role global health plays here at University of Wisconsin-Madison. As Jonathan has just outlined, global health is also what our students look for as they prepare to face our multicultural world. Global health brings our campus together in ways that we're still discovering and we hope will still evolve, giving us a 21st century opportunity to reshape and to continue to celebrate the Wisconsin idea. Dr. Frumkin is a fellow of the American College of Physicians, the American College of Occupational and Environmental Medicine, Collegium Ramazzini, and the Royal College of Physicians in Ireland. Dr. Frumkin's research interests are in the public health aspects of the built environment, climate change, energy policy, and nature contact. It is with great pleasure that I give you Howie Frumkin. Dr. Howard.
Well, it really is a treat to be here. This is just, as you all know, a beautiful campus. This is a beautiful facility. And the fact that you're all here on a night when you could have been off doing a basketball event is a tribute to the level of dedication and interest that people at this institution have. So thank you for coming. We live on an infinitely beautiful, complex, and precious planet. We depend on the planet for sustenance, support, inspiration, and well-being, what in slightly stodgy academic terms are called ecosystem services. We respond with appreciation, with awe and wonder, and at our best with a sense of stewardship. And indeed, we need that sense of stewardship. Our planet is fragile. The biosphere that supports us is as thick in proportion as a layer of cellophane on a soccer ball. And our planet is changing. The emerging field of planetary health proposes that Earth system changes are now so far-reaching that they drive a substantial and increasing proportion of the global burden of disease. We depend on stable Earth systems to survive and thrive. Environmental destruction amounts to self-destruction. This iconic image represents a safe operating space for humanity. The idea that there are limits that, if transgressed, may threaten not only Earth systems, not only human health and well-being, but the very basis of civilization. You'll notice climate change at 12 o'clock up at the top. You'll see land use change over to the left at 9 o'clock, both represented as in a zone of increasing risk. You'll notice biodiversity at 10 o'clock, divided into two parts, genetic diversity with high risk and unknown risk for functional diversity. You'll notice the stuff with which we're loading the environment, chemicals at 2 o'clock, aerosols at 4 o'clock, with not enough knowledge of where the limits are. Now, there's active debate around this image of planetary limits, the idea of specific boundaries rather than continuous variables, the relationships between global and regional trends, and so on. But it powerfully conveys the notion that we need to live within limits. We need to understand the consequences of approaching and crossing those limits and commit to wise corrective action. In the next few minutes, I'll offer several examples of the ways in which changing the planet and surpassing planetary boundaries threaten human health and well-being. Climate change is a leading example, but other global scale changes also impact health and well-being. I'll mention 4: chemical contamination, changes to water, changes to land, and biodiversity loss. For these 5 examples, the science paints a clear and sobering, if not yet complete picture. Global environmental change threatens human health and well-being. And the science, in turn, raises questions of both conceptual and ethical, questions with which I'll close. So let's start with climate change, perhaps the best recognized of the planetary changes that affect human health, operating through many pathways shown in this impossibly complex but oversimplified diagram. Some effects are primary and direct, such as those due to heat and severe weather events in the red box at the center. Earth system changes then lead to secondary effects, such as infectious disease risks in the purple boxes at the bottom. Tertiary effects, such as armed conflict and population displacement, are mediated by more diffuse and complex social disruptions in the green area to the right. And of course, these categories overlap considerably. Every important category of human suffering is affected: infectious diseases, non-communicable diseases, traumatic injuries, mental distress, and illness. Let's consider just the simple direct one, heat. And it turns out it's not as simple and direct as you would think. In fact, if you appreciate complexity, you will love heat. Heat-related medical diagnoses, from relatively benign heat rash to potentially fatal heat stroke, are well known. During heat waves, people die, especially the very young and very old, the poor and socially marginalized, and people with certain medical conditions. Rick, tell me if I get this right. The numbers can be frightful. 70,000 deaths during the 2003 European heat wave, 54,000 during Russia's 2010 heat wave, and uncounted thousands of people in India during the summers of 2010, 13, 15, and 16. People can adapt to heat, but only to a point. And with more frequent, more intense, and longer-lasting heat events coming, that point will be increasingly exceeded. But heat, usually considered a direct pathway, threatens health and well-being in less obvious and, I hate to say, but interesting ways. Violent crime increases on hotter days. Self-harm may rise as well. Some data show an association between heat and suicide. Heat seems to increase the risk of kidney disease, a problem best documented in low-income countries where workers toil in high temperatures without adequate rehydration. In hot conditions, it's more difficult to protect food and water from bacterial contamination. Diarrheal diseases such as Shigella rise during hot weather, and that was the most diplomatic picture I could put to document that connection. Hot weather undermines sleep, and sleep deprivation is a risk factor for many diseases. People reduce their physical activity during hot weather, forfeiting a powerful protection against cardiovascular disease, cancer, depression, and other conditions. Similarly, heat reduces work capacity to the point that economic output is declining substantially in very hot places, compounding poverty in these places. Workers are affected in another way. Workplace injuries rise during hot weather. Through these many pathways, from sleep loss to food poisoning to the deepening of poverty, heat threatens health and well-being. And heat is just one of the ways in which climate change undermines public health. A second planetary change is widespread dissemination of synthetic chemicals through the world's ecosystems. Plastics, which are polymers of simple molecules such as ethylene, propylene, and styrene, are emblematic. Large-scale plastic production began after World War II and has now reached 300 million metric tons per year, or about 40 kilograms for each man, woman, and child on Earth. This means that on average, each human being now alive will account for over 2,800 kilograms of plastic production over his or her life, or 30 or 40 times our body weight. Plastics are persistent. If Michelangelo had sipped water from plastic bottles while painting the ceiling of the Sistine Chapel 500 years ago, those plastic bottles would still exist. For every human being now alive, there is somewhere in the world about 1 metric ton of plastic. Over half of it is waste. some in large pieces, some pellet-sized, some broken down to microplastics. Where is this waste? Some is in landfills, some is in waterways, a common and heartbreaking sight in many of the world's major cities. Plastic generally floats, so it travels with currents and accumulates in eddies, forming patches that can be as large and imposing as islands. From streams, rivers, and harbors, the waste winds its way to the oceans, an estimated 5 to 13 million tons a year. Driven by wind and currents, the plastic seems to go everywhere, making this a planetary problem. It's been found in the deepest ocean trenches, in Arctic ice, in Mongolian mountain lakes, on remote island shores. The world's ocean systems tend to concentrate waste in the 5 great ocean gyres shown on this map. The highest concentration of plastic debris ever measured on a beach was on remote Henderson Island, on the western edge of the South Pacific Gyre, 5,000 kilometers from the nearest significant human habitation. The plastics permeate ecosystems. We now know that some birds confuse plastic bits with food and ingest the plastic, but cannot digest it. An estimated 90% of seabirds now have plastic in their bodies. The albatross is one such bird. Traditionally a sign of good luck for mariners, later a symbol of guilt in Coleridge's Rime of the Ancient Mariner, it takes on new metaphorical meaning in the Anthropocene as a graphic warning of our environmental recklessness. The seabird over the ocean as the planetary health equivalent of the canary in the coal mine. Nor are birds the only affected species. In one recent study, fish and shellfish from markets in Indonesia and California were assessed for plastic debris. There it was, in a quarter of the individual fish and well over half the species sampled in both countries. When we eat fish, we're eating plastic. And plastic isn't just plastic. About 7% of plastic on average consists of chemical plasticizers, flame retardants, and other additives. And plastics efficiently absorb synthetic organic chemicals to their surfaces. Many of these chemicals, such as polychlorinated biphenyls, are highly persistent in the environment, hence the term persistent organic pollutants, or POPs. Indeed, environmental loading with such chemicals is a defining feature of the Anthropocene. Now, POPs are fat-soluble. They bioconcentrate within the fat of organisms such as fish, cattle, and polar bears, and they're biomagnified as they move from lower to higher trophic levels in food webs. POPs are now globally distributed, even in ecosystems such as the Arctic, far from where they were ever produced or used. With POPs so widely distributed, human exposure is unavoidable. Population sampling, some of which we did at the CDC, shows nearly ubiquitous body burdens in human populations. Many of these chemicals affect neurodevelopmental, endocrine, metabolic, and other delicately balanced systems in humans and in animals. For example, chemicals such as PCBs, bisphenols, and some pesticides act as endocrine disruptors, blocking or activating receptors in sex hormone, thyroid, or other pathways. Evidence suggests a surprisingly wide role for these exposures in non-communicable diseases: diabetes, obesity, and lipid abnormalities, non-Hodgkin's lymphoma, cancers of the breast, ovaries, and prostate, thyroid disease, neurobehavioral disorders, and reproductive dysfunction. One recent study of Inuit people in the Canadian Arctic found that those with the highest blood levels of PCBs were 2 to 4 times more likely to have diabetes than those with the lowest levels. Now, we don't fully understand the geographic extent of global chemical contamination, its pathways through ecosystems, its full impacts on human health, to what extent these exposures account for rising trends in some diseases, where are the boundaries we should not cross. But it's very clear that this planetary change does no favors to ourselves or to ecosystems. The story of chemical contaminants in the oceans brings us to a third example of planetary changes with potential health impacts: changes to water bodies. Not only are oceans becoming fouled, not only are they becoming more acid as a result of carbon dioxide loading, but oxygen levels are declining in many places. The blue zones in this image represent hypoxia in the open ocean. The principal cause is climate change. Warmer temperatures decrease oxygen solubility in water and increase the rate of oxygen consumption through respiration. Moreover, warmer temperatures weaken ocean overturning circulation, and are predicted to reduce the introduction of oxygen from the atmosphere and surface waters into ocean interior. This image also shows red spots along coastal areas. There, climate factors also operate to reduce oxygen, but they're eclipsed by increased loadings of nutrients, such as nitrogen and phosphorus, and organic matter, primarily from agriculture, sewage, and the combustion of fossil fuels. These low oxygen zones can increase production of nitrous oxide, a potent greenhouse gas, reduce eukaryote biodiversity, alter the structure of food webs, and threaten food security and livelihoods. In both coastal and inland waters that are overloaded with nutrients, harmful algal blooms can occur. Human health impacts range from mild to severe, as suggested by the inventory of diseases on this slide. Health impacts can be compounded by economic impacts on fishing, recreation, and tourism. These events are becoming more common, a result of ocean warming, nutrient loading, and other factors. In coastal zones, acute outbreaks of hypoxia with or without harmful algal blooms can be catastrophic. One example is Bolinao, a town of 82,000 people on the west coast of Luzon Island in the Philippines. Repeated fish kills in recent years have wreaked havoc with local tourism and fishing. And local people who depend on fish for dietary protein, as over 2.5 billion of the world's people do, suffer repeated nutritional challenges. We're also altering the planet's river systems. This slide shows the dramatic increase in dam construction around the world. In some places, such as the Columbia River Basin where I live, river systems are fully built out. But in other areas, dam construction has only just begun. This image of one river basin in northern India shows existing dams in green, an equal number of dams under construction in brown, and fully 4 times as many dams that are in planning stages. This image shows a similar pattern in the Amazon basin. The red dots represent dams in use or under construction, and the far more numerous yellow dots show proposed dams. We are in an orgy of dam construction, as opposed to a dam orgy of construction. Now, what do we think about this explosion of dam construction? Well, in some ways, it's very positive. Energy poverty is a bad predicament. Reliable energy is a pillar of health and prosperity, and hydro is a relatively clean energy source. But dams come at a cost. River ecosystems are altered, species composition changes, fish populations can be seriously compromised. Large dam projects can displace large numbers of people, with attendant risks ranging from infectious disease to depression and anxiety. Changing conditions along rivers can raise the local risk of malaria, schistosomiasis, and other infectious diseases, and even trigger the formation of toxic materials such as methylmercury. Many of these risks can be managed, and the trade-off between clean electricity and healthy rivers is context-dependent. But it's clear that we're changing river systems on a planetary scale, and that human health can be affected. One more water example, not surface water, but groundwater. The depletion of major aquifers by human water withdrawals is well documented. Of the world's 37 largest aquifers, human withdrawals have depleted 21 beyond their recoverable tipping points. This cartoon shows the High Plains water system, principally the Ogallala Aquifer, which many of you may know. It's close to here. This picture on the right shows water level changes during the past half century. Levels have declined dramatically, especially in the southern portion of this system. The red and pink areas indicate declines of over 100 and in some cases 150 feet. This will certainly aggravate long-standing outmigration from rural areas in the Great Plains as wells run dry. In combination with the stresses of climate change, it also likely portends substantial changes in our nation's food production patterns. These directly and indirectly affect people's health and well-being. A fourth example of global environmental change that affects human health is land use change. Human population growth and resource demands have led to dramatic expropriation of land globally. We've transformed as much as half the world's ice-free land surface, much of it from grassland or forest to cropland and pasture for grazing. These changes threaten many species, including Homo sapiens. Consider 2 examples. The first is infectious disease. A land use change and resulting ecosystem alterations can propel diseases as diverse as malaria, schistosomiasis, Lyme disease, and West Nile. Many mechanisms operate, from changes in microbial ecology to increased contact between humans and vectors. A recently published example is instructive. Scientists based at the University of Vermont were interested in the effect of degraded watersheds on children's health, specifically on diarrhea, the second leading global cause of death among children under 5. They studied nearly 300,000 young children in 35 countries, focusing on measures of watershed quality, the influence of upstream livestock grazing, people, and tree cover on downstream water quality. The researchers found that more intact tree cover in the upper watershed reduced downstream rural children's probability of diarrhea. 30% more tree cover at the top of the watershed was as protective as a classic public health intervention, sanitation infrastructure. Healthy tree cover in a watershed is good for human health. A second example of the impact of land use change on health comes from palm oil production in South Asia. Production is increasing as a result of demand for biofuels in Europe and food in India, Indonesia, and China. Oil palm plantations affect local ecology. They're far less biodiverse than primary forests. To clear tropical forests in Indonesia for palm oil production, as well as for other purposes such as timber plantations, fire is commonly used. The resulting smoke blows in defined ways, affecting populations in Indonesia and the Malay Peninsula. Such smoke contains fine particulate matter. In fact, it accounts for over 250,000 global deaths each year. Researchers based at Harvard have studied the Indonesian fires, combining data on land types, land use, fire occurrence, wind patterns, smoke composition, and health outcomes. Among their findings, the Indonesian fires caused roughly 11,000 excess deaths in the region in an average year. In an especially bad year, 2015, the toll was an order of magnitude higher, at just over 100,000 excess deaths. Not only that, the forest combustion and peatland loss contribute to climate change. And dietary palm oil contains highly saturated fatty acids that may raise the risk of heart disease and other non-communicable diseases. The final form of global environmental change I'll mention is biodiversity loss, which has accelerated dramatically during the Anthropocene. This has numerous potential impacts on human health, but I'll just mention 2 examples: pollinator loss and fisheries depletion. Pollination by insects is an important form of reproduction for more than 35% of the annual global food production by volume. At least 87 major food crops and up to 40% of the world's supply of some nutrients, such as vitamin A, depend on insect pollination. Pollinators are declining in many parts of the world, probably for a combination of reasons, including habitat loss, pesticide use, and parasitic infestation. Pollinator loss can reduce the amount of fruits, vegetables, nuts, and seeds in the diet, contributing to vitamin A and folate deficiencies. A recent analysis projects that a 50% loss of pollination would cause about 700,000 additional deaths worldwide each year, mostly as a result of increased ischemic heart disease and stroke due to decreased fruit and vegetable consumption. Fisheries depletion has emerged as a global problem as well, with about 90% of fisheries now at or beyond maximum sustainable levels of exploitation. This problem goes well beyond the episodic hypoxic episodes I mentioned earlier. For many populations, fish are a bedrock dietary source of protein, of micronutrients, often in a highly bioavailable form, and of omega-3 fatty acids, mainly from the oily fish. Climate change will intensify fisheries depletion in coming years. One study projected that more than 10% of the global population could face micronutrient and fatty acid deficiencies due to fish declines over coming decades, especially in low and middle income nations near the equator. Fortunately, there is some indication that with aggressive management, collapsed fisheries can recover, as may be happening with the North Atlantic cod fishery, which abruptly collapsed in 1992. And aquaculture is to some extent replacing wild fish catches. But most aquaculture depends on external feedstocks that may themselves be unsustainable, and challenges such as disease in the farmed fish, chemical contamination of the farmed fish, genetic contamination of wild fish stocks, and pollution near fish farms must be addressed if sustainable aquaculture is to be achieved. Well, these 5 sets of examples, climate change, chemical contamination, degradation of water resources, land use changes, and biodiversity loss, together paint a compelling picture. Human disruptions of planetary systems threaten human health and well-being. Those who are most at risk are those who live each day with high levels of risk due to poverty and deprivation. This has been a grim litany. Indeed, planetary changes are threatening human health and well-being, even civilization as we know it, on a frightening scale. But the news is not all bad. Some planetary changes may offer benefits, such as higher agricultural yields or more physical activity in cold areas that are becoming warmer. Advancing technology is offering cleaner energy, higher agricultural yields with lower environmental impact, more efficient buildings. As importantly, the steps we need to take to address planetary challenges, such as climate change, yield a range of co-benefits, such as stronger communities, cleaner air, and more wholesome food. These advances and co-benefits are the topic of another talk. And if I can't do it, Jonathan really knows this well. The planetary health approach addresses planetary changes by placing humans at the center of our thinking. This is a redrawn picture of the planetary limits I showed earlier. It shows the same processes, climate change, ocean acidification, and so on, now with the label ecological ceiling, a reminder that each parameter has a limit and that overshooting that limit is to be avoided. But this drawing makes clear that the center of the circle is empty. What belongs in there? Well, within the circle, we can situate people and the resources we need to thrive. This image shows several of those resources, basics such as food and water, opportunities such as education and employment, networks of information and social support, human rights such as equity and political voice. Here, overshoot isn't the problem. Instead, it's shortfalls. A minimum level of each factor, here labeled the social foundation, is also needed to assure human thriving. The donut that results represents the safe and just operating space for humanity, characterized by a regenerative and distributive economy as described by the Oxford economist Kate Raworth. There are limits beyond which we shouldn't go, and there are limits below which we shouldn't go. Tackling both sets of challenges is a defining feature of planetary health. In the meantime, the threats I've described call on us to change our thinking as scientists and as global citizens in some fundamental ways. First, we need to acknowledge and live within limits. We've all lived all our lives, everybody in this room, during a time of plenty, unprecedented in human history, enabled, of course, by our profligate consumption of energy and materials propelled by ever more powerful technologies. Those of us in wealthy nations are no more conscious of our extravagance than fish are conscious of water. And as we've learned from recent behavioral economics research, we humans are wired not to confront limits. We're biased towards short-term thinking, we discount future consequences, we resist risky change. We need to work to replace profligacy with restraint, extravagance with modesty, wastefulness with thrift. Second, we need systems thinking. Every serious thinker about sustainability or climate change or human affairs in general knows that reductionist linear thinking misses the mark. Nowhere is this more true than in planetary health. But too many of our institutions remain siloed. Too many donors are infatuated with silver bullet technical solutions rather than aiming for patient, long-term adaptive management of complex systems. In my own field, medicine, why do we still require prospective students to have studied chemistry, physics, and calculus, but not ecology and evolutionary biology? We need habits of thinking and institutional arrangements that are based on systems. Third, we need a sense of urgency. Our house is on fire, and we need to act accordingly. Our scientific discourse is typically dispassionate, but passion in this setting is no sin, it is a necessity. 50 years ago, discussing a very different emergency, the Vietnam War, Martin Luther King wrote words that are deeply appropriate today. We are now faced with the fact, my friends, that tomorrow is today. We are confronted with the fierce urgency of now. In this unfolding conundrum of life and history, there is such a thing as being too late. Procrastination is the thief of time. As it was then for Reverend King, so it is now for us. We must confront the fierce urgency of now. Fourth, we need intellectual humility. Modern science and technology, animated by positivism, have delivered untold benefits to humankind. But they've also brought wicked problems and profound dilemmas. Science and technology do not offer all the answers. We scientists need to be open to other intellectual traditions, to faith traditions, and to the traditional ecological knowledge of indigenous peoples. This will take us beyond our comfort zones, exactly where we need to be as we stretch towards solutions. Let me close with a word about ethics. As a medical student and young physician, I learned and took seriously the principles of biomedical ethics. Respect for autonomy, non-maleficence, beneficence, and justice. These principles guide some very sound decisions. Don't treat a patient without his or her consent. Don't withhold information from a patient. These are well and good, but they're not nearly enough. Biomedical ethics has been far too confined to hospitals and clinics. We need an ethic that recognizes everybody's right to have access to the clinic in the first place, and not only to the clinic, but to all of the precursors needed for a fully expressed and healthy life: education, housing, political voice. We need an ethic that recognizes intergenerational responsibility. Our obligations extend well beyond our own lifetimes. Finally, we need an ethic that extends from humans to the more than human world. As much as we bear responsibility for each other, we bear responsibility for other species and for ecosystems. Our ethic must be grounded in our place as part of the larger world we share. We live in a golden age. Prosperity has increased around the globe, poverty has been reduced, and human health has never been better. But in the words of the Rockefeller Foundation Lancet Commission on Planetary Health, we have been mortgaging the health of future generations to realize economic and development gains in the present. As scientists, we've increasingly uncovered and quantified the human health impacts of disrupting Earth's systems and crossing planetary boundaries. Impacts from climate change, chemical contamination, water and land use changes, and biodiversity loss. We need to continue this task with ever greater sophistication and accuracy, creating and using scientific frameworks appropriate to the complexity of the challenges, and with intellectual humility. Just as important, we need to act on the science with a passion for sustaining life, with urgency, and with a drive for social and environmental justice, ever mindful of the great privilege we have to choose the legacy we leave. Thank you.